Welcome to this lesson on the midsegment theorem. We'll begin by talking about what a midsegment is, first of all. And so, in a triangle, there are three midsegments. The midsegment is a line segment that's going to connect two midpoints. So, if I take side QP over here, the midpoint here is at X. So, if I also take side QR, the other midpoint for QR is at Y. And if I connect X and Y here, I've created a midsegment. Well, obviously there's two other midsegments. There's midsegment XZ and midsegment YZ. Together, they create the midsegment triangle. So this triangle right here is called the midsegment triangle in the middle. So these are our three midsegments. And this is our midsegment triangle. Pause the slide if you need to. This is the triangle midsegment theorem. Two things you need to keep in mind if you have a midsegment. The midsegment is going to be parallel to the base. So in this case, we're looking at DE and AC as being parallel. But also, the midsegment is going to equal half the base. So DE is going to be half of AC. So you've got two things to keep in mind there. Parallel and then the relationship of a 1-to-2 relationship. Pause the slide if you need to. So here I want to find the measure of BD. BD is a midsegment. You can see that BD right here is going to be half of AE. We see that AE is 17, and so if BD is going to be half of 17, then we'd say it was 8.5. Going through that, we use the midsegment theorem to say that BD was half of AE. We plug in the 17 for AE and take half of it. And so BD has to be 8.5. It's a very straightforward calculation that you're going to do with the midsegment theorem. Here I want to find the measure of angle CBD. So let's make sure we see where that is. CBD is going to be this angle right here. So I want to find CBD, and what I know is by the fact that BD is a midsegment, that it is parallel to AE. So I could say that it's congruent to this angle. The only problem with doing that is I don't know what this angle is. I don't know what angle BAF is. So yes, they're congruent, but that doesn't help me. So I'm going to have to look elsewhere. Well, if I turn in my mind a little bit and look this way, look at line segment AC as being parallel to the midsegment FD, so this is the midsegment I'm focused on, FD, then what I see is that angle FDB and angle CBD, the one I'm looking for, are alternate interior angles, because this is my transversal, BD. So those would be alternate interior angles, and since I can see that angle BDF is 26 degrees by following this line in here, then I can say that angle CBD is also going to be 26 degrees. So we started with the fact that DF and CA had to be parallel, and then we used our alternate interior angles theorem, which allowed us to say that the angle had to be 26 degrees. So now we want to find the measure of JL. Well, JL is a length, and it is measured here. And what I know is that JL is going to be half of the midsegment PN. So if this is the midsegment here, I'm sorry, I said that backwards. PN, the midsegment, is going to be half of JL. PN here, this 36 length, is going to be half of JL. So that's what we use the midsegment theorem for, to set that up, that PN is half of JL. And then we plug in what PN is. and we'd have 36 equals 1/2 JL, so we'd multiply both sides by 2. And 2 times 36 is going to give us 72 for the measure of JL. So JL, so you can think of it as PN is half of JL. The midsegment here is half of the base, or the base is twice the midsegment. Here I want to find PM. PM is this midsegment right here. I'm marking it for you. And it's going to be half of this base. So PM is going to be half of LK. That's using the triangle midsegment theorem. And then I take half of the 97. So I've got 48.5 for the measure of PM. So again, the calculations aren't difficult on this. It's just recognizing the midsegments in the triangle. Okay, here I want to find the measure of angle MLK. So MLK is this angle right here. And what I can see is that I have a midsegment here at MP, and it is going to be parallel to LK here. So corresponding angles will be congruent. So I can see that MLK is going to have to be the same as JMP by the corresponding angles postulate. So it's going to be 102 also. So we start with the fact that they're parallel using the corresponding angles postulate. State that those two angles have to be equal in measure. And then plug in. So we get 102 degrees for the measure of angle MLK. So now what I need you to do for class is to take the quiz that'll follow on the next 2 slides. Bring that to class to turn in for a grade. Here's the first page of the quiz. Pause if you need to. Here's page 2. Bring those 5 questions to class, and I hope you have a great day.